Assalamu alaikum, Aisha. Am I audible? Okay. So in the last class, we have completed over here. We have completed the reactions of a metal with a cold water, then reaction of a metal with steam, then reaction of a metal with dilute acid, then we did the reaction of a metal with oxygen. Now, the next thing that we are going to start is reactivity series. So this is the reactivity of metals. When we move down this series, the reactivity decreases. In between, there is a hydrogen, which is a non-metal. So potassium, sodium, and calcium are the most, reactive metals. Then magnesium, aluminium, zinc, iron, and lead have a moderate reactivity. And from copper till platinum, these are the least reactive metals. So what we are seeing that as we move down this series, the reactivity decreases. The reason is we have observed this in the previous classes. For example, if you, the potassium when potassium reacts with cold water, it reacts explosively with the cold water. If you recall, we have observed the reactions over here. So from these observations, we have concluded. Then sodium just floats on water, it dissolves readily, and it just forms a bubbles on a surface, but very slowly. So this indicates about their reactivity. Okay, so this is the reactivity series, and this reactivity series is actually not provided to you in the exam. They're just going to provide you a periodic table. So you have to memorize these. Just these in the same sequence. That is most important. Okay, just copy this down, then I will make you understand what we can conclude from this reactivity series. Aisha, am I audible to you? Today is 31st, right? Yes, now am I audible?
Yes, sir.
Okay. So the important thing over here is that you have to remember this in the same sequence. So when we compare sodium and potassium, which is on the top, between sodium and potassium, which is on the top, what is the symbol for potassium? K. So which is on the top? K, potassium. So it means potassium is more reactive than sodium, and sodium is even more reactive than calcium. So among all these, the most reactive element is potassium, and the least reactive element among these is, among all of them, is Pt, platinum. Okay. Yes, everybody done? Yeah. Okay. Okay. Yes, Aisha, are you done as well?
Sir, you weren't audible before, so I don't know.
Yeah, I was just giving the time to the students to note it down. Now I'm going to explain it, okay?
Okay, sir.
Okay. So now we got to know from this that which one is going to be more reactive than the other one, right? So the one which is more reactive have a property or have a ability to displace the one which is less reactive from it, from the compound. That's what second point explains, that the on the top is the one which is more reactive, can displace the element from its compound which is below it. So it means if there is a potassium, so potassium can able to displace any metal which are below it from their compound. For example, if I react potassium with sodium chloride, so from sodium chloride, potassium can displace sodium. If I react potassium with, let's suppose, zinc sulfate, so zinc sulfate is a compound, and potassium have a ability to displace zinc from zinc sulfate. Are you guys getting this point? Is this understandable? Yes, Aisha, is this understandable to you as well?
Yes, sir.
On the other hand, the element which is below cannot displace the element from the compound which is above it. For example, if I use lead and I have a magnesium hydroxide, so lead cannot able to displace magnesium from magnesium hydroxide because lead is less reactive than magnesium. But if I have a magnesium and it is reacting with lead hydroxide, so magnesium have a ability to displace lead from lead hydroxide. Is this clear now? Yes, Ania? Okay, yes, Aisha, do you understand?
Yes, sir.
Okay, so the rule is if the metal is reactive, then it forms the compound which are stable. So normally the one which is more reactive stays in its compound form and does not become element again easily. And the one which is less reactive does not stay in its compound form and can become element easily. Is this understandable? If you guys have any confusion, do ask. Yes, Aisha? Okay, now have a look at these two reactions. In the first reaction, there is a sodium metal. It's an element and it's a compound, right? Aisha, did you understand?
Yes, sir.
Okay, so the compound have a zinc in it and an element have a sodium. So see, is sodium is more reactive than zinc or not? Yes. Because if you see, sodium is over here on the top and zinc is over here. So it means sodium is more reactive than zinc. So it means sodium can able to displace zinc. So in the product, zinc becomes separate and becomes an element. Is this clear? Yes, Asha, is this clear to you as well?
Sir, can you explain it again?
Yeah. See, if you look at the position of sodium and zinc, sodium is above and zinc is below sodium, right?
Yes, sir.
So it means sodium is more reactive, right?
Yes.
So it means sodium have a ability to displace the zinc. So if it displaces the zinc, so zinc becomes alone and becomes an element like this. Is it clear?
Yes, sir.
Okay. Now we have to make the compound when if sodium displaces the zinc, so obviously sodium is going to bond with oxygen and form sodium oxide. So for that, we will look into the periodic table to find their charges and then make the correct formula. So if I look for sodium and oxygen, so if you see over here, sodium is where, in which group it is? So it means what charge sodium atom have? Sodium ion have? Yes, +1 as it's in group 1. And if you look at oxygen in periodic table, you will find it over here in which group it is? Yes, in which group oxygen is? Look again. In the sixth group. So if it's in a sixth group, then what charge should oxygen ion have? Minus what? Why? How many electron it needs? 2. So then -2. Because it is in a sixth group, so it means its outermost shell have a 6 electrons, and to complete the outer shell 8 electrons are needed, so it means it is needing 2 electrons. So if it gains 2 electrons, it will become -2. Is this clear? Yes, Aisha?
Yes, sir.
Okay, so oxygen have a charge of -2. So if sodium have a charge of +1 and oxygen have a charge of -2, then what will be the formula? Yes, what will be the formula? What will be the formula? of when we have these ions, then how will we make the formula? We will move this 2 in the subscript over here and this one in the subscript of O. So if we place a 1 in the subscript, there is no need to write it. So the formula becomes Na2O. Is this clear how we made the formula? Why you keep forgetting how to make the formula? Yeah. Okay. Aisha, did you understand?
Yes, sir.
Okay. So if you look at the equation, my equation is balanced now. How? How many zinc over here? 1. And how many zinc over here? How many oxygen over here? How many oxygen over here? How many sodium over here? How many sodium over here? So sodiums are not balanced. So to balance the sodium, we have to put a 2 over here. This makes the equation balance. Is this clear? Yes, Aisha?
Yes, sir.
Yes, Sania? Okay. Now, let's have a look at the second reaction. If you see over here, we have provided with the 2 elements, one metal and one compound. So metal is a copper element, right? And compound is magnesium oxide. So look at the positions of copper and magnesium. Copper is over here and magnesium is over here. So does copper displaces magnesium? Good. Yes, Aisha?
No, sir.
No. Very good. So it means no reaction occur. So you will just write no reaction. Is it clear now? Okay. Now I'm going to give you few equations and you need to make those equations with the help of the reactivity series. Okay. Aisha, have you noted down the reactivity series?
Yes, sir.
Okay. Now, complete the equations. So the first equation is magnesium is reacting with, let's suppose, zinc sulfate. Then zinc is reacting with copper nitrate and platinum is reacting with iron nitrate. Now, complete these 3 equations. Okay, Aisha, if you complete it, you can WhatsApp me, okay? Yes, Aisha, did you able to make the equations? Yes, Sanya? No? Will you able to identify whether the reaction occur or not? First tell me that. Yes. Had you made the equations? Okay. Just tell me about first one. If you look over here, does magnesium displaces zinc, yes or not? Yes. Yes, Aisha, is this clear to you as well?
Yes, sir.
Okay. So it means in the product we will get a zinc alone. That's for sure. Now tell me, does zinc displaces copper or not? Yes. So it means that we are going to get copper alone. Yes, Aisha, did you understand this as well?
Yes, sir.
Okay. Does platinum displaces iron? No. Yes, what do you think, Manahil? No reaction. Yes, Aisha, isn't it? Because see, platinum is the at the bottom of the reactivity series and iron is above, and so iron in the compound. So it means here there will be no reaction. Is this clear to all of you? Where is this? It's sulfate. So there is a sulfate ion, SO4 2 minus, that is a negative ion. So till here, is this clear to everyone? Yes, Aisha?
Yes, sir.
Okay, so if now what we need to know, we have to identify the charge of magnesium and sulfate to make the formula of the compound formed, and we have to know the charge of zinc and nitrate to make the formula. So remember, sulfate, you are not going to get its charge from the periodic table. You always have to memorize it. So what is the charge of sulfate, Manahil? You have noted down in the ionic bonding. Just check from there. The charge of sulfate and nitrate. Magnesium, if you see where the magnesium is present, see over here. Magnesium is in group 2. So it means magnesium have a 2+ charge. And for zinc, you have to remember that zinc always have a 2+ charge. Sulfate, SO4. What is the charge of sulfate ion? Sulfate is -2 and nitrate is? How? How? Can you think if there is a 1 + 2, then other must be +2? There is no possibility of the other end having a positive charge because the oppositely charged ions come together. So what is the charge on NO3? It's -1. Okay. So in the first case, when the positive ion and the negative ion have a same charge, we just combine them, that's it. Okay. And here, the same thing happens that 2 moves over here, and if 1 moves over here, so we don't need to write the 1, so we will write Zn, and then we will write NO3. Now 2 is moving in the subscript of NO3, and NO3 means there is a nitrogen and oxygen both, right? If I put a 2 like this, then that doesn't make sense because that 2 is going to apply on both the atoms. So I have to enclose this in a bracket and then put 2. That's how we practiced in ionic bonding as well. So it means that zinc nitrate will form with this formula. Is this clear? Yes, Aisha, now did you understand?
Yes, sir.
Yes, Sania? Yes, Khatija? Oh, sorry. Manahil. Today Khatija is absent. Okay. Aisha, you were present in the class where we did this. No, you were present when we did metal with the water, right? Okay.
Yeah, I wasn't in the last class.
But you were, yes, but you were in the class before the last one where we did metal with water, right?
Yes, sir.
Okay. So, okay. Now, the next thing that we have to start is corrosion. Okay. When we talk about corrosion, it is basically we call an attack of oxygen or a reaction of oxygen. Whenever a metal and oxygen reacts, usually corrosion occur. Like you usually observe corrosion in iron, the materials made up of iron, like the stands of the chairs or the door gates where the iron is there. After some time, you will find it becomes reddish brown, right? And that is because it is corroded. Okay. So we call that corrosion a rusting, and that the term rusting is used for iron only or its alloys. Okay. When iron rusts, it turns red brown because when it's an iron, first understand then note down. Okay. When it's iron, it have a no charge, but when it gets rust, it got a +3 charge and it becomes a ion. So when it's only metal, its color is silvery gray. But when it loses the electron and becomes this ion, it turns red brown flakes. See, when there is a rust, it doesn't stays intact like the metal do. It flakes or it starts to flakes off from the surface, right? That's what happened. Yes, Aisha, did you understand?
Yes, sir.
Okay, so this is the formula of rust. So when iron get rust, it becomes like this. Then it have a oxygen bonded to it, and there is a water as well. So we call it hydrated iron 3 oxide. Okay. So note this down. I will be just coming in 5 minutes after opening here. If you follow then this is proved, then I will come. Yes. Yes. Aisha, have you completed? Yes, Aisha, did you complete? Done? Okay. Now, when we talk about the conditions of iron, rusting. So iron only gets rusted in moist air. When we talk about moist air, it means it contains both oxygen and water. So when iron gets interacts with oxygen and water both, then only rusting occurs. Otherwise, rusting will not occur. For example, and there is another important thing: whenever there is a seawater or salty water, the rate of rusting increases. That in the salty water, rusting occurs more readily than as compared to the normal water. Okay, so here, if you look, there are three examples. One, there is an iron nail that is dipped in water, and on the above of that water, there is an oil layer. So what that oil layer is doing, it is stopping air to be in contact with water. So there is only water over here, and that's why rust does not occur over here. Here, there is a dry air inside, so oxygen is there, but there is no water over here. So that's why again rust does not occur. And here there is a water and there is a air as well. So oxygen and water both are present. So that's why rust occur in this third test tube. Is this understandable? It's a dry air. So oxygen is there. But here we have placed a bung to make it not come in contact with the moist air from the outside, and there is no water inside, right? So if there is only air and no water, so rust does not occur. Is this clear? Yes, Aisha, did you understand?
Yes, sir.
Okay, just note these down. Done? Yes, Aisha, are you done?
Yes, sir.
Okay. Yes, Sania? Okay. Then there are the ways to prevent rusting, that how can we protect iron from being rusting. So the first one is either we can do a greasing and oiling on the surface of iron or the object. Normally that's what we do on the hinges of the doors or the joints of the metals where we put greasing, so it will not undergo rust. Then beside this, what we else we can do? We can coat the metal, the iron or its alloy with the plastic. That also does not allow it to be in contact with water and oxygen, and again it protects it from the rusting. Then if we do the paint on the surface, that paint also protects the inner surface of the iron from water and air. Fourth one is the galvanizing. In galvanizing, what we do, we dip the iron into a melted zinc or tin, other metals. And when we dip in it, we got a layer or a coat of the other metal on the surface. And as the other metal comes on the surface, it gets coated, the iron gets coated with the other metal, so that other metal does not allow air or oxygen or water to come in contact with the iron atoms, and that's how we can protect the iron from uh, rusting. Then we have a sacrificial protection. Okay, what we will do in sacrificial protection? In sacrificial protection, we usually connect iron with the more reactive metals like zinc and magnesium. So as zinc or magnesium are more reactive than iron, so they do not let iron to react with oxygen or water. Instead, they start reacting with oxygen and water and consuming themselves. That's why we are calling it sacrificial protection, because when they protect iron and gets used up themselves, so they are sacrificing them for iron. So that's why we call it sacrificial protection. Okay, is this clear? Yes, Aisha, did you understand?
Yes, sir.
Okay, just note these down. There are two reactions equations for sacrificial protection as well. First, just note this down, then we will discuss. Yes, Aisha, till where you have completed? Yes, Sania, till where you have completed? You are writing sacrificial protection. Okay. Yes, Aisha, till where you have completed?
Yes, sir.
Okay, you are also doing sacrificial protection? Okay. So this is what happened during the sacrificial protection, that magnesium element and zinc element becomes ions by using their electron, and these electrons are ready whenever the oxygen loses its electron. These electrons are provided to iron ions, and as a result iron is restored again. So as the magnesium and zinc ions are being used up, so the pieces that we have connected initially, we have to replace them periodically to keep iron protected from the rusting. Is this clear? And that the normal, we are going to observe it in ship's hull, that in the hull of the ship we place a magnesium or zinc to keep the whole ship uh, prevent from rusting. Is this clear? Yes, Aisha, did you understand? We will end our class over here, and in the next class we will continue further. Yes, Aisha, if you have any questions, do ask, please. Yes, Sania. Yes, I will be going to send it in the group. Yes, Aisha, any doubts, any queries?
No, sir.
Okay. Are you done? Okay, Allah Hafiz.